right, so next we've got someone from Team Grad School. We've got Ed McAssey talking about another very important issue. Here you go, sir. And he's going to talk to us today about climate change, problems, predictions, and what we can do. All right.
On Friday, President Obama set aside $183 million for the western part of the United States. This upper panel shows why. This is a map of drought in the western U.S., and the darker colors here represent more pronounced drought. So you can see they're really focused in California, and this has really big impacts on crops, livestock, as well as drinking water. While we can't generalize from a single weather event to global climate change, this is certainly adding to a body of evidence that these drought periods are becoming more and more common and are certainly suggestive of global warming. So what we can see up here in the upper right is a prediction. It's a computer model comparing average temperatures in the year 2100 to present day. And the fact that it's orange and red indicates that we predict it's going to be warmer. The temperatures are, on average, going to increase over time. So as plant biologists, we're concerned. We want to understand when and where we can plant our crops in this changing environment. And this is a crucial question. To get at that question, for my dissertation, I'm studying wild sunflower. It's a species with a large range, so it encounters a lot of different environments, all the way from Mexico up into Canada, actually. And so what you can see here are actually two of the extremes. This is a Texas individual and a Canadian individual. And the first thing that jumps out at you is just the huge size difference. Texas plants are taller. But there's a couple things you can't see. One is that I planted this Canadian individual 2 weeks later compared to the Texas individual, so it flowers more quickly. We think this is an adaptation to the short growing season seen in Canada. Another thing you can't see is that their fatty acid profile is very different. We think that the fatty acids in Canada derived plants are actually adaptive for their germination in cooler temperatures. So we think we can understand what an adaptive phenotype is in the wild populations, and maybe this can help with adapting crops to climate change. But wild populations are also a tool for outreach, and that's what we're seeing over here. As a part of a module I've developed for Hillsman Middle School, I'm growing wild carrot and lettuce, as well as high-yielding cultivars. And what we're going to do is keep some well-watered, drought others, and let the students measure the phenotypes. Hopefully they take away two things. One, hopefully they are in awe of the domestication process. Oh wow, this is what a wild carrot looks like. But beyond that, hopefully they can see the impact of climate change on the food we eat, and hopefully that builds a lasting connection, and maybe they'll be the future scientists to tackle the problem. Thanks.